Has anyone ever heard the expression cargo cult before? So I've heard it before. People kind of throw it around. I never really understood what it meant. And I think the story behind it is kind of interesting. It refers to this period in World War II when the US military sort of set up shop on a bunch of South Pacific islands from which they would stage missions and whatnot. And supplies would get airdropped into those islands. And I think as part of the deal, so that the military could hang out and run their operations from these islands, they shared these supplies with the locals. And for that period of time, this was like, for the locals, they were getting a lot of stuff for free that they weren't getting before. It was sort of like a time of, what's the word I'm looking for? It was great. And then when the war ended and the military went away, the cargo planes stopped coming. And this was bad. So cults started developing in which the natives were sort of like trying to create these rituals of what they saw the US airmen doing. Like they would start trying to operate the runway. They would go into buildings. They would do military processions where they would dress up like military people. And they were just trying to kind of like coax a plane out of the sky to drop more stuff on them like they were used to. And so I think it's an interesting story, and I think it sort of leads into this topic of what I call cargo cult web performance, which is where we kind of have these rituals when we're writing code. We just sort of like sit down and we optimize things, not necessarily because of like good science, but because we saw it written down in the past or we practiced it in the past. And so it should hold true today, but that may not necessarily be true. The context has probably changed. Browsers change dramatically year after year. Networks change. The devices that we use change, mobile devices versus desktop web browsers. And so how do we get here? Why do we find ourselves sort of like replaying these rituals? It's not entirely our fault. There's a lot of outdated information out there. There's deprecated books, right? Some of my favorite web performance books are really dated right now. High Performance Websites by Steve Souders, Even Faster Websites, High Performance JavaScript by Nicholas Sakis. Those came out in 2007, 2009, 2010. That's a long time. Blog posts that because of PageRank kind of like rise to the top of your Google searches because they've just been linked to a lot. And they may be out of date. Best practice guides, Stack Overflow answers, similar problem there where old answers kind of get a lot of votes. They come to the top. So when you're looking for an answer, you kind of hit those instead. Deprecated performance analysis tools, page speed, why slow, aren't necessarily up to the date to the minute. Maybe you just go to a website that you really like and you kind of see what they're doing and you think that you should mime that practice yourself. And of course, conference talks like this one, which for future posterity, if anybody's watching this video, the year is 2015, and everything that I say from this point forward probably doesn't make sense anymore. So today, we're going to look at three things that I think are kind of interesting. One is hostname sharding. I'll get to that in a moment. The other one is like sort of for loop array caching. This is like trying to write faster loops by caching the length property. And then using JavaScript to insert script elements to kind of get better asynchronous behavior out of script loading. So first of all, hostname sharding. Who's familiar with hostname sharding, just as like a practice? OK, I want to say like 30%. To understand hostname sharding, you got to kind of understand how the web, like the origins of the web, in the sense that in HTTP 1.0, in the specification, it says that a web browser should only download 2 resources at a time from a single origin. And the reason that they wrote that was they were afraid that if a web browser opened up a whole bunch of connections at once to a web server, the web server would become overloaded. So they kind of wrote this as like a best practice guide. This is what web browsers should do. But browsers over time sort of like subverted this rule, and they started introducing more connections. And when you get more connections, and assuming that your throughput is good, you can load websites faster. So this is kind of that same figure where on the left we have 2 connections per origin. On the bottom we have 4 connections per origin. And you can see that kind of the waterfall gets a little tighter. It's loading faster. And then hypothetically, then if you have a browser that has 8 connections per origin, and again, this is like working off an example that there's only a single origin on this website, then that waterfall looks really fast. But for a long time, we did not have browsers with 8 connections per origin. So we kind of came up with this little trick, which is, well, what if we just introduced more origins to a website? Right? You've probably seen this pattern before, where you see www1, www2, CDN1, CDN2, 3, 4. And the idea here is that the browser will think that those are sort of like different servers, and so it'll open up, 2 connections per origin. So in these sort of figures, this is the same level of parallelization as the last example, but it's a browser with only 2 connections per origin, and we've introduced 2 on the bottom and then 4 origins on the right. And this is still a fairly common practice. If you kind of look around the web, I kind of fired up the Alexa Top 100 and checked out a bunch of websites. There's a lot of popular websites that still use multiple static hosts. Google Plus, I think that's still around. Tumblr, Alibaba, The Verge, eBay, Netflix. Netflix uses 11, which is pretty interesting, and I'll come back to that in a bit. This is an interesting thing I found. I was checking out Stack Overflow to see what people were talking about this. This is somebody who they were using Google PageSpeed in 2014. This answer is from 2014. And Google PageSpeed told them that multiple host names was faster. So they decided to take this to the logical extreme, and they gave every image a unique host name for ultimate parallelization. And to his credit, they were asking if this was a good idea. Nobody answered. I probably should have answered. I feel like a dick now. The thing is, this is not really a big deal anymore for a variety of reasons. One, which is that I've alluded to earlier, the number of connections that a browser will open per origin is much higher now. The lowest today is 6. Chrome and Safari and IE899 load 6 per origin. Firefox and IE10 do 8, and IE11 does 13. I don't know what it is about 13, but that's what they're doing. But it's more than that. There's some extra gotchas. One, even if you have 6 host names on a website where you're distributing images, you're just loading a whole bunch of images, and you visit that page with Chrome, hypothetically speaking, 6 times 6, I should be able to download 36 images at a time. But that doesn't actually work, because browsers internally have like a cap of a single asset type that they will load. Chrome is the most aggressive in this regard. They'll only load 10 of a single asset type at once. So in this case, sharding beyond 2 domains is dubious. Other browsers, I think it's around 16, 17. Another reason why this has become not so much of a big deal is, when you were making this decision about hostname sharding in the past, you were sort of weighing the costs of opening, like doing another DNS lookup to another domain, opening up another connection, versus parallelization. But as the web sort of becomes more HTTPS everywhere, the cost of opening a connection goes up. Not only do you have to do a DNS lookup and TCP slow start and this other stuff, you've also got to do a secure handshake, and that takes time. So if you have 11 host names, that's 11 handshakes. You start to see these decreasing returns. And then also, you're probably aware, but HTTP2 is coming. It's already in browsers, but support is going up. It sort of changes the landscape of how browsers connect to different servers and download resources, and kind of, this is not an HTTP2 talk, but the short of it is that multiple host names is bad for HTTP2. Unfortunately for all of you, the HTTP2 talk is parallel to this one, so you won't be able to learn anything about it. Steve Souders, who first sort of wrote about hostname sharding in his book, also, several years later came back and basically said, you should probably not use more than 2. And this was 2 years ago. Here he was saying that for non-speedy browsers, you should use 2. you can replace that with HTTP2. So far, I've spoken to you in like the theoretical. Hypothetically speaking, these DNS lookups, these handshakes, they cost time, parallel image requests, et cetera. But there's evidence that actually reducing the number of static hosts actually improves performance. Etsy 2 years ago made a change from 4 static hosts to 2, and they split tested the results. They saw across the board a 30 to 50 millisecond improvement, and on image-heavy pages, that improvement was even better. What's really interesting is that on mobile, they saw the biggest level of performance, half a second faster on average. And the theory is that in sort of like crappy latency environments and lower power devices, opening up multiple connections has a higher overhead on mobile. Now, earlier I showed you, some websites and how many static hosts they're using. But really, a lot of progressive and popular websites are also moving away. New York Times, YouTube, Twitter, Facebook, et cetera. You might be wondering, Netflix is on this slide with 1, but they were also on the other slide with 11. How can they be both? What I noticed is that Netflix, if you visit Netflix over HTTPS, you'll get a single host name. If you go over HTTP, you'll get 11. So it could be that Netflix, maybe you've heard, but they're transitioning to HTTPS for everybody. So this is just a case of they're deprecating that old, that sort of like old flow, and everyone's going on this new, faster one. Maybe they recognize that HTTPS has this extra overhead, and so we're only going to use a static host in that environment. Another note about Twitter and Facebook, et cetera, is that even though I put 2 static hosts here, it's not really obvious that they're intentionally trying to put their assets on different origins for parallelization. Usually what the case is that they have user-generated content on one domain and their CSS style sheets, JavaScript, et cetera, on another domain. So it could just be sort of like an architecture decision to have them completely separated. So that's all I have to say about hostname sharding. Let's look at another thing, which is looping. And by looping specifically, I mean doing a for loop and caching the array length. I think this is a pattern that people are pretty familiar with. It looks like this, where on the top we have this pretty simple loop. I'm just going to declare like an iterator variable I, and then at every point I'm going to check the length of an array, and then I'm going to do some operation on the array inside of the loop. Now, some time ago, people started writing this version, which creates a new variable len or length or whatever you want to call it, and initializes it to the length of the array at that point in time, the moment when the loop starts. And the prevailing theory is that doing a property lookup on length on the array every time you iterate through the loop is slow. So we know that that value doesn't change. Why don't we just cache it, and it should be faster. This has sort of been written about at length. There are articles out there that are high in page rank that tell us not only should you be caching this length attribute, but to not cache the length attribute is super bad and you're terrible. People are still writing this on the time. Writing this all the time. You can go on GitHub and do a code search, and you can see that this pattern is still pretty common. There's a Stack Overflow answer right now, which is if you search this and you look on Stack Overflow and you just want to know the answer, what should I be doing? There's an answer here that says, currently, the fastest way to iterate, do a for loop is to cache the length variable. But I find this a very tricky answer because this answer was first given in 2011, but it was edited in February 12th of this year. So is currently from 2011, or is it from this year? I'm not sure. So is this still true? In that Stack Overflow answer, the author actually links to a JSPerp test, which he is using as evidence to kind of show us that for loop caching is the way that we should be doing it. So I decided to run that myself and see what results I saw. And the results for me were very different than the ones proclaimed sort of in that Stack Overflow answer. This is kind of like a normalized chart where the fastest for a given browser is at 100%. So the way to read this is that whether I cache it or I don't cache it is more or less equivalent on all modern browsers. Sort of the last point in time at which this seemed to really make a difference is IE8, which I've circled at the bottom, which is about 78% slower. But again, this is a JSPerp test, and this is sort of suspect, what's happening inside of the loop. In this case, it's just like assigning a value to an array. Pretty simple stuff. You might be wondering, how is it that this code is identical? If we have this really tight loop, wouldn't you think that that property lookup, theoretically speaking, is a little bit slower, and we should cache it? Like, it sort of makes sense when you think about it. And the reason that this doesn't make a difference anymore is that browser JavaScript engines are also pretty smart, and they can kind of look at the code, and they can make a similar sort of assessment and do an optimization themselves. So on this next slide, it's probably hard to see up here, but this is a program called IR Hydra generated this. What it does is it takes sort of like a JavaScript program and shows you sort of like the pseudo assembly instructions that V8 will use internally when it's running that program. Now, it's not important exactly what the instructions are here. What's important is this next slide, which is if you run the program through the cached version, and the generated code is actually the same. The only difference is really like some of the registers change or whatnot. So, sort of the lesson here is that this is Slava Igorov. He's a V8 developer, and he's written about this phenomenon at length, and he's explained how V8 intentionally identifies this pattern and optimizes for it. And he basically says, you should really start thinking that when you have these trivial optimizations you can make, that maybe the browser already does it for you. Right? If you can do it so easily, then probably they can too. There's a bit of a catch to this, which is I also ran this JSPerp test on mobile. I was trying to be very thorough, and I found that, yeah, on mobile, it's a little bit slower if you do not cache the length property. But it's really small. This JSPerp test is, just assigning a value to an array in a loop. If you started doing any trivial kind of work inside of this loop, you can imagine that 95% becomes 98%, 99%, and then it becomes a fraction of a fraction of a fraction of a fraction of your entire application. I just thought I'd look at this because I think it's kind of interesting. But personally, I think that if we're really like micro optimizing at this level, you've probably lost sight of how best you could optimize your application. All right. So finally, we're going to talk about dynamic script insertion. I didn't really have a good picture that captured dynamic script insertion, so this is a plane that says Dynamic Airlines on the side of it. So what do I mean by dynamic script insertion? Maybe you're familiar with this pattern, but at the very top, I have a very simple blocking script include. Are you guys familiar with the concept of blocking with scripts? I think people are just lazy with opening up their hands, and they understand. Typically, when you have a blocking script in this manner, the idea is that the browser can't load subsequent scripts, or it can prefetch them, but it can't execute them because a script can change the DOM. It can do document.write. It could change the structure of your HTML, and so what comes after, what is after the script element right now may not be true once the script executes. So in the past, we kind of came up with this little hack where we determined that if you use JavaScript to create a script element, and then you append it to the DOM, the browser will sort of treat this as an asynchronous script. It won't block on anything. And this was considered a very good practice for a long time. Nicholas Zakis wrote in 2009, and then again in his book, High Performance JavaScript, that this is the best way to load JavaScript. I also wrote about it in my book, which is from 2013, and I said this was a pretty sweet way to do things. That's only 2 years ago. And who does this? If you've seen this pattern, you've probably seen it in a Google Analytics snippet that you've put on your site. All kind of third-party scripts do this a lot. So Google Analytics, Mixpanel, Chartbeat, WordPress has their own analytics. So if you're using like a WordPress blog, they're inserting something like this. Widgets discuss Facebook comments, JS module loaders like Require.js and Lab.js. I'm not sure if we're using Lab.js anymore. There's also script tag managers, which are products that sort of like act as a proxy or a manager of all of your third-party scripts. And you can split test on them, et cetera. And they do a similar technique. The thing is that we sort of missed something when we came up with this technique. And this is a relatively new observation or discovery, which is how dynamic script insertion plays with the CSS Object Model. Now, CSS Object Model, what does that mean? Well, every time you load a style sheet, there's an API for accessing sort of like the current state of styles in your page. Just like how you access the DOM and you get elements by tag name, you can get computed styles. And that represents the current state of the CSS OM at any given point. But for this to work, whenever you execute like a script, the CSS has to be up to date. So if you have this pattern where you're loading a style sheet, and then you execute some JavaScript right after it, the style sheet has to complete loading before the browser will evaluate the JavaScript, because you might write code like this. This is me querying document.body for its margin. So what that means is that if we sort of extrapolate that pattern, and we have this example where I have a style sheet, and then I have a dynamically inserted script right below it, what's going to happen is that this inline script won't even execute until that style sheet has finished downloading, is parsed, and is evaluated. And this is a relatively new discovery. We didn't know this until 2014, or certainly nobody was talking about it. What that means is that, imagine that your CSS file is particularly slow. Maybe you've got a 3 megabyte style sheet. I don't know. In this example, this is basically the example from the last slide where you have a couple of dynamically injected scripts, and they don't evaluate until that really long, slow CSS file loads. And that's bad. We were hoping to get asynchronous parallelization, and we didn't get it at all. It ended up being far worse, because let's pretend that we actually use the old and busted blocking script. Browsers will actually parallelize blocking scripts. They will. Browsers can look ahead, and they can see that there's a script tag coming up, and they'll sort of prefetch it, just kind of assuming that you're gonna evaluate that when the time comes. So in this blocking example, here I'm using two scripts below the style sheet. Firefox will fetch the first script, and it won't evaluate it. It will just kind of hold on to it until the CSS finishes, and then it will evaluate it, and then it downloads the next script. So it's sort of like, have we been doing this all wrong? Because we've been advocating for this dynamic script insertion pattern for so long, and really, in some cases, it's actually slower. And like I said, this was Ilya Grigorik from Google discovered this in 2014 and wrote about it. Of course, there is a third option called the async attribute, and it's an HTML5 property. It's supported in most browsers, but admittedly not all. I'll get into a sec. And the async attribute basically tells the browser that this script can evaluate whenever. And if it can evaluate whenever, it doesn't care whether the CSS object model is ready or not. So the browser can download it and execute it whenever it pleases. So if we use that same example again, and we use the async attribute, we get that intended parallel download effect that we were looking for, and non-blocking, et cetera. One thing to note is, yes, async attribute is sort of the way that we should be doing it today, and we should probably start using it because IE 10 and up support it, and pretty much every browser supports it, and it's kind of at the point where we should be using it. The reason that we had dynamic script insertion was because async didn't exist. So this is a pattern that emerged when there wasn't a better solution, and we just kind of kept using it. And a final note about this that I think is pretty interesting. HTML5 boilerplate, which is a project that maybe you're familiar with. It's really popular. They give you sort of like a boilerplate HTML page to work with that's really well formed and whatnot. They have a Google Analytics snippet in there for you, sort of by default. They just kind of assume that whatever web page you're going to build has Google Analytics. And there's a pull request opened a day ago that basically says we're not going to use the default dynamic script insertion method for the reasons I just told you. We're going to switch it to async. And there's Paul Irish below who's basically thumbs-upping it, and I understand that that will be merged pretty soon. So that will become the default mindset going forward, I think. So those are kind of like the 3 things I wanted to look at. Hopefully, somebody learned something. I certainly did when I was developing these slides. I just have a couple closing thoughts, which is don't always believe what you read on the internet, or at least consider the date of what you're reading. And this can actually be really tough, because sometimes you're reading an article and it says it's from 2015, but really they're just parroting something that was written in 2012, right? They didn't do their original research. So you're really interested in original research and the date of that original research. Always benchmark your own stuff, because even what I've explained today may not be, while it might be really great for slides and sort of examples of things to avoid, it may not be applicable to your website. Like, in all honesty, we probably don't have style sheets that take 2 seconds to load. So maybe that's not as big of a concern for you. But a bigger takeaway, I think, is that benchmark your own stuff every year or every couple years, because everything changes all the time. I was tweeting at the Etsy engineer who did that original sort of like Etsy test case, and they're already going to start reevaluating the changes that they made 2 years ago for today, because now HTTP2 is sort of coming into vogue. And then as a final thought, it's been said, always bet on JavaScript. I think similarly, we can think that you can always bet on browsers. They're always adapting. They're always getting smarter, and they're always getting faster. And sometimes those guys are smarter than us. So that's all I have to say. Thank you very much for listening. Thanks. Music almost came off. Just a couple acknowledgments. A lot of the stuff is based off of research by Steve Souders, Ilya Grigorik, Guy Pojarny, Slava Igorov, Jonathan Klein, Paul Irish, Nicholas Sakis. I'm doing office hours today if you'd like to talk to me. And that's it. Thank you very much.